Here we'll do some extra practice for graphing quadratic functions. Our goal here is to take the function y equals -1/2 times x minus 2 squared minus 1 and find the vertex, the y-intercept, and any x-intercepts. We'll begin with the vertex. To find the y-coordinate for the vertex, look to the number that is outside of the parentheses and not multiplied by it. Our y-coordinate for our vertex is -1. To locate the x-coordinate of the vertex, look to the number that is added or subtracted inside the parentheses. We have -2 here, but remember that the sign inside the parentheses is reversed. Therefore, for our vertex, our y-coordinate is -1, and our x-coordinate is the opposite of -2, which is +2. Be careful to look out for your sign when you're doing the vertex. We'll place that on the graph, and we'll find 2, -1 by going right 2 and down 1. Now for the y-intercept, let's recall that any time you are doing a y-intercept, you are going to let x equal 0. That means in our function, we are going to locate where the x is and replace it with 0. So our function will be y equals -1/2 multiplied by the parentheses. We will have 0 minus 2 rather than x minus 2. Then we'll subtract 1. Let's handle the arithmetic. 0 minus 2 gives -2 squared. We'll have that multiplied by -1/2 and then subtract 1. -2 squared gives +4. We multiply that times -1/2 and then subtract 1. -1/2 times 4 will give us -2, subtract 1, which gives us a y value of -3. Therefore, our x is 0 and our y is -3. Therefore, our point is 0, -3. We'll place that on our graph by starting from the origin and going down by 3 units. Now let's try to find the x-intercepts. For the x-intercepts, we are now going to let y become 0. So once again, we'll go back to our original function, and rather than saying y, we'll say 0 instead. We'll say this equals -1/2 multiplied by the parentheses x minus 2 squared minus 1. It's easy to get stuck on this part, but our goal is going to be to get the parentheses by themselves. For that reason, we will add 1 to both sides. This will cancel out the 1 on the right and give you +1 on the left. Now, in order to continue, we'll have to get rid of the -1/2, and if you're stuck on this part as well, we will multiply both sides by the reciprocal of -1/2 in order to cancel it out. The reciprocal of -1/2 is -2/1. When we multiply by this reciprocal on the right, the 2 on the bottom of the -1/2 and the 2 on the top of the -2/1 cancel, and the 1's cancel as well. All that's left is a negative times a negative, which is a positive, and so both of the fractions have effectively canceled out. On the left side now, we just have -2/1 times 1. -2/1 times 1 will give us a -2 equals x minus 2 squared. However, last time we were in this position, we took a square root on both sides. But if you try to take the square root of a negative number, this will give you an imaginary answer. That square root of -2, with regards to the x-intercept, we can say dne, meaning there is no x-intercept. Because we have no x-intercept, what we'll have to do is find two symmetric points instead. We'll do that on the next page. What we're going to do to get the other symmetric point is measure both the x and y distance between our vertex and the y-intercept. I'll label my vertex and my y-intercept on the graph. You may be able to see on the graph that if we start from the vertex and we want to go toward the y-intercept, we would have to go left by 2 units, which I'm drawing in orange. We would also have to go down by 2 units, which I'm also drawing in orange. We'll make a note of that here. To get the symmetric point, we will start from the vertex, and instead of going left 2, we'll go right 2. However, we will still go down 2. So now we'll draw from the vertex a marker that it tells us to go right by 2. We'll have to modify the x-axis for that, and then draw in orange that we're going right by 2, and then still going down by 2. And then we're going to draw a new marker at that position. If we want to find where that's located, again, we'll start from the vertex and make a note that we've gone right 2, then down 2. If we go right by 2, this will increase our x by 2, but if we go down 2, that will lower our y by 2. If we do our math, our new point will be 2 plus 2 on the x is 4, and -1 minus 2 on the y is -3. That will be our symmetric point. Now to complete this graph, we will connect all 3 of those points using a curve. This completes our sketch of this graph. You'll do this process anytime you don't have 2 x-intercepts.